towards the center. So friction force is responsible for providing the centripetal acceleration which is required for the object to move in a circle. So friction force will be equal to centripetal force, that is mv square by r. Now the value of friction force is mu n, where mu is the coefficient of friction and n is the normal force. Since there is no motion in the vertical direction, the forces in vertical direction will be 0, the net force. So we have n minus mg is equal to 0, or n is equal to mg. So if we replace n with mg, we'll get mu mg is equal to mv square by r. M will cancel out, so v square is mu rg, or v is equal to root under mu rg. So for an object which is moving in a circular track and the track is having coefficient of friction mu and the radius of circular track is r, its velocity should be equal to under root mu rg. Now we'll see the case of smooth bank track. So suppose there is an object which is moving around a circular track of radius r, and the circular track is banked at an angle theta. So here what will happen is the vertical component of the reaction force m, this will balance the weight, so we have n cos theta is equal to mg, and the horizontal component will provide the necessary centripetal force. So n sin theta will be equal to mv square by r, where m is the mass of the object and v is the velocity at which it's traveling. So from equation 1 we have n is equal to mg by cos theta. So if we put this equation in if we put the value of n in the equation 2, we get mg by cos theta into sin theta is equal to mv square by r, or we can cancel out m, so v square by r will be equal to g tan theta, or v will be equal to root under rg tan theta. So if an object is traveling around a circular track which is banked at an angle theta, then its velocity will be given by root under rg tan theta. Now let's take the example of rotation of binary system. A binary system consists of two objects of mass capital M and small m, and these two objects move on circular orbits due to mutual force of attraction around an axis which passes through their common center of mass. Now let's say this with the help of an animation. So here we have a binary system having two objects, one with mass capital M and the other with mass small m. These two objects are being acted upon by a mutual force of attraction F. Because of this force of attraction, these two objects move around a circular orbit, with the center being the center of mass of this binary system, and the radius of the circular orbit for mass capital M is capital R, and for mass small m it is small r. So we can write the following equation. Since suppose this point is C, since C is the center of mass, it means that m into PC is equal to capital M into CQ. Now PC is nothing but the radius small r, so mr is equal to capital M, and CQ is nothing but the radius capital R. So this is one equation we get, and it's clear from the figure that r plus r is nothing but a, where a is the distance between the two objects, that is a is nothing but PQ. So from equation 1 and 2 we can write that r is equal to mr by small m. So if we put the value of small r in the equation 2, we get r into 1 plus m by m is equal to a, or r is equal to ma by m plus m. Similarly, we can get small r is equal to ma by m plus m. Now let's say this is equation 3 and this is equation 4. Now the value of the force which is acting on these two particles, F, will be equal to m omega 1 square small r for the object at P, and it will be equal to capital M omega 2 square into capital R for object at Q. Now since these two forces must be equal, so from here we get m omega square r is equal to capital M omega 2 square r, or now we can replace the value of small r and capital R. So m into small r, that is capital ma by m plus m into omega 1 square is equal to capital M into capital R, and capital R is ma by m plus m into omega 2 square. Now here we can cancel out these expressions, that is small m into capital M into a by m plus m. So from here we have omega 1 square is equal to omega 2 square. So this means that both the objects are moving with same angular velocity, and this is the reason that the distance between these two objects will always remain the same, that is the distance between these two objects will always remain a, where a is nothing but small r plus capital R. Now let's fix the frame of reference to one of the object in binary system and find out what is the angular velocity of the other object in this frame of reference. Let's see the animation first. So here we have our binary system having object P and object Q. The mass of object P is small m and the mass of object Q is capital M. The object P is moving around in a circular orbit with angular velocity omega. Now if we fix the frame of reference at object P, so this frame of reference is accelerating because a centripetal acceleration having the value r omega square is always acting on this object. So in this frame of reference, the forces which is acting on object Q are capital F, which is mutual force of attraction, and a pseudo force which is capital M times centripetal acceleration of object P, that is r omega square. Now for an observer with object P, the object Q will appear to move around a circular orbit with angular acceleration omega dash square. So these two forces are responsible for the centripetal acceleration of object Q. So this will be equal to m into capital R into omega dash square. So from here we can get the value of omega dash square, which will be equal to f plus mr by mr, or omega dash is root under f plus mr by m into capital R. So let's see the animation first. So here we have our binary system with having object P with mass small m and object Q with mass capital M. Object P is moving around a circular orbit with angular velocity omega. So the centripetal acceleration of object P would be r into omega square, where r is the radius of circular orbit around which object P is moving. Now let's fix our frame of reference at object P. So in this frame of reference, the forces acting on object Q would be F, that is mutual force of attraction, and a pseudo force which is equal to mass of the object Q into centripetal acceleration of object small m, that is m into r omega square. So these two are the forces, that is F plus m r omega square, which is acting on object Q in the given frame of reference. Now these two forces are responsible for generating centripetal acceleration for object Q. So if in this frame of reference the object Q is moving with angular velocity omega double dash, then this will be equal to m times a into omega double dash square, where a is the distance between object P and Q. So here we can write omega double dash square is equal to f plus mr omega square by ma, or omega double dash will be equal to f plus mr omega square by capital Ma. Now we have already seen that if these two objects are moving with angular velocity omega and omega dash, then omega was equal to omega dash, and m into small r was equal to capital M into capital R, and r plus r was equal to distance between the two objects, that is a. So from here we got